So our objective, I can solve and graph quadratic equations. So quadratic equations, you don't need a Ferrier model. We covered some of this yesterday with quadratic functions. Remember that? Yes. So therefore, quadratic equations, to clarify, quadratic equations are two variable equations where the highest degree is 2. Some of the examples, like I said, you don't even have to copy this. Just pay attention. Some of the examples, x squared plus 3x plus 2 equals y, x squared minus 9 equals y, y equals 3x squared minus 11x plus 6. So, those are examples of quadratic equations. They look very similar to quadratic functions, right? However, non-examples. Look at these. X squared plus 3x plus 2, and negative 3 plus x equals 10. So think about it. Why are these non-examples? Talk it over with the neighbor, please. So we see for quadratic equations was that it's a two-variable equation, and the highest degree is 2. We said that this is not, and the highest degree on this one is 1. These are not equations. So, since we arrived at Chapter 9, and Chapter 9 requires more steps, so now copy these 7 steps. Here we go. It says, step number 1, solve for y. Step number 2, or in parentheses, set in standard form. Once again, step number 1, solve for y, set in standard form. Step 2, substitute 0 for y. Substitute 0 for y. Step 3, factor the trinomial. Factor the trinomial. Step 4, set each factor equal to 0. Set each factor equal to 0. Step 5, solve for the variable. Solve for the variable. Step 6, graph using the x-intercepts and the y-intercept. Graph using the x-intercepts and y-intercept. And 7, check. Check. Copy those easy steps. Okay? So once again, 7 steps, and this is all to solve quadratic equations by factoring. Okay? Copy this example number 1. Example 1. Example number 1 says, solve the quadratic equation by factoring and check your answer. The equation they give us is x squared plus 8 equals y plus 6x. Solve the quadratic equation by factoring, check your answer. X squared plus 8 equals y plus 6x. Copy that. Once again, the problem says solve the quadratic equation by factoring, check your answer. So they give us an equation. According to the steps I gave you, step 1 was to solve for y. Here's my equation so I can see both sides of the equal sign. There it is. Okay, I'll stop. Here it goes. So, to leave y by itself, I need to get rid of this plus 6. How do we do that? Subtract 6x, subtract 6x. However, in parentheses it said, write it in standard form. So now I'm taking you back to polynomials. Remember standard form? Highest degree to lowest degree. What is my highest degree out of these 3? X squared. Next one is minus 6x. And then the last one plus 8. Bring down this. Step 2. Substitute 0 for y. I'm going to change y. Substitute 0. Bring everything else down. X squared minus 6x plus 8. Step 3. Step 3. What does step 3 say? Factor the trinomial, you're saying, but it's an equation. Well, if I was to cover this, do we know how to factor this? Yes. First of all, I would try and see if there's a shortcut. Square root of the first? Yes. Square root of the last? No. So that means I need to open up parentheses. Factor the first term. Power Rangers. Negative 6 goes down here. That's my sum. 8 is my product. So what factors of 8 add up to negative 6? Negative 4 and negative 2, or negative 2 and negative 4. Are we there so far? Therefore, this is x minus 4, x minus 2. However, now we are dealing with what? With equations, which means I write equal to 0. Step 5, set each factor equal to 0. Is that true? Did I skip a step? Oh, solve for the variables, my bad. So I'm going to solve this one. Step 5 is solve for the, that means step 4, we need to set each one equal to 0. So check this out. I'm going to write this. X minus 4 equal to 0. X minus 2 equal to 0. From there, solve for the variable. Plus 4 plus 4. X equals 4. Plus 2 plus 2. X equals 2. And this takes you to the beginning of the year. Remember when we were in chapter 2? From there, these have a name. These are called roots. They're also known as x-intercepts. Or in Algebra 2, we call them zeros. All those three names. But specifically, the ones I want you to pay attention to is this one, roots and x-intercepts. X-intercepts, what does that mean? That's where our graph will cross the x-axis. You're saying, I don't see it, Mr. Kiva. Let me show you. Because doesn't it say solve and graph? Solve a quadratic equation by factoring. But I'm saying in the steps that I gave you, didn't it say that we're going to graph step number 6? Okay, here he goes. Pens down, eyes up here. Here's my coordinate plane. And my computer's taking forever. Okay, there it is. All right. X equals 4. This is my x-axis. 4 is about right here. The other one, x equals 2. X-axis, 2 is about right there. My y-intercept. I need my y-intercept to graph. So now, everybody look up. If I was to cover this part, what do you see? 6x plus 8 equals y. Doesn't this look like a linear equation? What would be my slope if I was to ask you? You would say 6 over. So what would be my y-intercept? 8. When quadratic equations, we no longer have a slope, but we still have a y-intercept. What did we say our y-intercept was? 8. So that one we put right there. Now we can graph it. Copy that, please. So it says, solve the quadratic equation by factoring and check your answer. So here it doesn't say graphing, but the reason I do the entire process is you guys can see the actual connection from one thing to the other. However, if they say solve the quadratic equation by factoring, did we factor here? Guys? Is this factoring right here? Yes. When we set each one equal to 0 and we find the values of x, this right here is our solution. We would be done. Like the homework is going to ask you, check your solve the quadratic equation by factoring. All you have to do is this process. However, I ask you to do the following, which is the graph. Why? Because I want you to see the connection. So what am I saying? I'm saying that the solution to the equation is known as what? Are known as the x-intercepts. Does everybody understand that? That's where we get the 4. That's where we get the 2. They're the x-intercepts. Okay, that's why we substitute y for 0. Now, some of you are still like, kind of like, your noodle's still going 100 miles an hour. Let me take you back when we did linear equations and I asked you to graph using the x and y intercepts. Remember I gave you something like this. 2x plus 2y equals 12. And I said, you can use the cover-up method. Remember that? We can cover this one up, solve for this one, and it gives us y. Solve for that one, gives us x. However, I remember doing something like this. X, y. Oh, this is y. Substitute 0 for x, and then later on substitute 0 for y. Remember that? And when we substitute the y for 0, that's how we get our x-intercept. Well, guess what? What did we substitute here? 0 for y. That's how we get our x-intercepts. Okay. So, am I done? No. What's our last step? Check. So let's check. So I'm going to write check right here. And then I'm going to bring, if we look up, I'm going to bring this equation, the one that's already solved for y. I'm going to bring this one over here, but instead of writing the equation with the variables, I'm going to open parentheses for the variables. Parentheses squared minus 6 times parentheses plus 8 equals parentheses. So, I'm going to check one of the points that I plotted. And at this point, I'm going to use this one, the x-intercept 2. But the equation has x and y. That means I need two numbers. So what is my coordinate for this one? 2 and 0. Look at the point. Where is it at? At 2. And what is y? 0. So therefore, x is 2, y is 0. So let's see. What is 2 squared? 4. Negative 6 times 2, that's negative 12 plus 8 equals 0. 4 minus 12, that's negative 8 plus 8. What is negative 8 plus 8? 0, and that is true. Now, some of you are thinking, but why did we have to go from here to here? I know it's to find the x-intercepts, but this is called a property. I want you to label that, and I'll explain it right now. Everybody look up. I want you to box here where the factors are at equal to 0, and we're going to label that ZPP. ZPP. You done with ZPP? Okay, here we go. ZPP. And I'll explain what it is. Here it goes. So, pens down, eyes up here. At the beginning of the year, I remember I covered a commutative property of multiplication. I said, if we have 2 times 3, the product is 6. Does the order matter how we multiply it? No. Same thing with 3 times 2. It's also 6. Are we there? However, from there I said, we covered a property with 0. And I said, 2 times 0 is 0. 0 times 2 is 0. How about if I do 0 times 7? What is that? 0. What about 7 times 0? 0. Are we there so far? And so on and so forth. So does it matter which number times 0? So what if I do this? A times 0 is 0, or 0 times B equals. So it doesn't matter what it multiplies by, it's always 0. However, I want you to think about this next part. Don't say it out loud, just think about it. What if I have A times B equals 0? Okay, hold on, give me a second. So, think about it. I had A times 0 equals 0. 0 times B equals 0. But now I have A times B equals to 0. So you're saying, I'd say that A could be 0, or B could be 0, or both. Are we there? Does that make sense? But we don't know. That's why I need to make sure I label it and let to remind me that this could be 0 or this could be 0. Now let me go back to the problem that we had. Watch. This times this equal to 0. Do you agree with that so far? Yeah, because we factored it. So this times this equal to 0. So what it's saying is that this could be 0 or this could be 0. Is that correct? So that's why I wrote x minus 4 equal to 0 or x minus 2 equal to 0. Does everybody see it? Let me bring it back over here because I think I still sense a disturbance in the force. Here it goes. It's like this. This times this equal to 0. Sorry. This times this equal to 0. Are we there? So what could this be? What could this be? So what if I had but here I had an A, that's why I wrote A equal to 0, B equal to 0. But instead of A, let's say I write x minus 2. What would I write? X minus 2 equal to 0, This one was x minus 4, so then I write x minus 4 equal to 0, because either one could be 0. That's why we do this step, the zero product property. Okay? Yeah. What's that? You can check with the other, but for right now, I'm going to check just that one. Okay? All right. Any questions? Let's go to the next one. Example number 2. Copy this down, please. You don't need the instructions anymore. You already have them written down. Just write example number 2. Example 2. And write y minus 7x equals x squared plus 10. Let's do this one together. Here we go. I'm going to draw a line down my equal sign just so I can keep organized. And step 1 says solve for y. What's next to y? Negative 7x. That means we need to add 7x. Add 7x. And we bring down the y, the equals, and this side has to be in standard form, so I start with what? X squared plus 7x plus 10. Are we there so far? Substitute y for 0, or 0 for y. That becomes 0 equals x squared plus 7x plus 10. So step 1, solve for y. Step 2, substitute 0 for y. Step 3, factor the trinomial, or factor the equation. So let's see. What do I do from there? Open two parentheses. Let's see, can I take a shortcut? Let's see, square root of the first? Yes. Square root of the last? No. So therefore, factor the first. Power Rangers, we got 7. We got 10. What factors of 10 add up to 7? 5 and 2. 2 and 5, doesn't matter the order. So I'm going to write 2 and 5. This is x plus 2, x plus 5, and you bring down the 0. Next step, set each factor equal to 0. X plus 2 equal to 0. X plus 5 equal to 0. Are we there so far? Let's solve for the variable. Minus 2 minus 2. X equals negative 2. Minus 5 minus 5. X equals negative 5. And these are my roots, my x-intercepts, my zeros. But since they're asking us to solve, these are also my solutions. Solutions. However, we're not done. Step 6, the 2 steps that I added at the end, we need to graph. Here you go. Let's see. Let's graph my first x-intercept is negative 2. Let's see. 1, 2, negative 2 is right there. The other one is negative 5. 1, 2, 3, 4, 5. Negative 5 is right there. And what else do we need? Our y-intercept. So let's see. Let's look at the equation that's already solved for y. And what is my constant? 10. And that goes up here. And we graph our parabola. Here it goes. I'm going to start with the y-intercept, and I'm going to match it to one of the roots. Here it goes. Bam. Everybody see that? Once again, what are our solutions from this graph? Negative 5 and negative 2, also known as the roots or x-intercepts. Are we there? What's that? And the last step, we do what? Check. I rewrite this equation, this one, the one that has the y in it. But instead of y, I open parentheses equals parentheses squared plus 7 parentheses plus 10. So now, I can check using these two. But in reality, if I wanted to ask you to check a point from that function or that equation, check this out. I can check any point on this parabola. So could I check this point? Yes. Yes, and it should be true if I'm correct. But if it's false, that means that you did something wrong on your graph. Does that make sense? So check this out. I'm going to test this point. What is the coordinate for that point? 0, 10. It's 0 of x, 10 of y. So let's see. Y is 10. X is 0, 0. So let's see. I bring down the 10. What is 0 squared? 0. What is 7 times 0? 0. Bring down the 10. What is 0, 0 plus 10? 10 is 10 equal to 10? Yes, that's true. So once again, any point on that parabola should be true. If it's false, you made a mistake. Let me repeat that again. Any point on the parabola should be true. If it's false, you made a mistake. This is where the mistakes are going to come. Everybody look up. Some of you are going to make mistakes here. Look up. When you do here, when you do the inverse, minus 2, some of you forget to bring down the negative, and you might write x equals 2. So what would happen if you substitute that in here? It's going to be false. So therefore, you're going to have to go back and check your work. We got it? Example number 3. Copy this one. And by the way, what is the property called here? Right here? ZPP. Yeah, you know me. Okay. Example number 3. Copy this one. Example number 3 says, solve the quadratic equation by factoring. Check your answer. And we have y equals 2x squared plus 5x plus 3. Okay, so step 1, solve for y. Isn't it already solved for y? Step 2, substitute 0 for y. Bring everything else down. 2x squared plus 5x plus 3. Are we there so far? So step 1, solve for y. Step 2, substitute 0 for y. Step 3, factor the trinomial. So let's see. Open two parentheses. However, notice this one has a coefficient. You're like, oh man, I can't do this and that, so I need to go straight to my Power Ranger. The middle term is 5. What goes on top? 6. Why? Because since it has a leading coefficient, I need to multiply times 3. That gives me 6. So factors of 6 are 2 times 3, and 2 plus 3 is 5. However, those cannot go here. Pens down really quick. This is where some of you still get confused. Here it goes. All I'm going to do, pay attention please, all I'm going to do, I'm going to rewrite this entire equation right here. 2x squared plus 5x plus 3. You see that this is this. I just rewrote it. Are we there? Okay. The reason I rewrite it after I start doing the factoring piece, because this one has this number. I cannot factor this here and here. Okay? Unless it only had, look at the previous one. What did it have? X squared. That's why I'm able to do just x and x. You guys see that? So check this out. This is where some of you still didn't understand. Hopefully this will clarify. I just rewrote this, but instead of 5x could be broken down into 2x plus 3x. Because what is 2 plus 3? 5. So all I do, I replace this with 2x plus 3x. Now we group. What is GCF for these two? 2x, and we're left with x plus 1. What's GCF for these two? 3. And what's left? X plus 1. So now, what are my factors? Let's see. What's the same here and here? X plus 1, that goes here. X plus 1. What's left? 2x plus 3. 2x plus 3. And now we're back on track. I bring down the equal sign and I bring down the 0. Are we there so far? That's an ugly X. Let me replace that. Look like somebody squashed a cockroach or something. There it is. All right. So now that we're here, we have our factors. What do we do from there? What is the property? ZPP, zero product property. That means we need to set each factor equal to 0. So now I'm going to continue down here. X plus 1 equal to 0. 2x plus 3 equal to 0. From there, let's solve. Minus 1, x equals negative 1. Minus 3, 2x equals negative 3. Divide by 2. X equals negative, what is this? 3 divided by 2 is 1.5. These are my roots, my x-intercepts, or my zeros. So for right now, we know that these are my solutions. Right there. Let's graph it. Okay, so let's see. What's my first x-intercept? Negative 1. Negative 1's right there. Negative 2 is over here, but it's not negative 2, it's negative 1.5, which is right in between there. Negative 1.5. So, let's go to where our equation is equal to y. What's our y-intercept, everyone? 3. And I plot that point right there. And let's graph our parabola. Nice and straight like mine. I know, it kind of like, but it's not me, it's the little tablet. It doesn't let me do meter stuff. Let's check. Here we go. Check. I'm going to rewrite this equation. But parentheses, everything with parentheses. Parentheses equals 2 parentheses squared plus 5 parentheses plus 3. So, turn to your neighbor, let them know which point are you going to choose to substitute in there. Okay, I heard somebody say negative 1. So therefore, what is that coordinate for negative 1? Negative 1 and 0. So therefore, y is 0, x is negative 1. So you substitute negative 1 in there. So this is 0. What is negative 1 squared? 1. What is 2 times 1? 2. Plus 5 times negative 1 is negative 5. So, I'm going to negative 5 plus 3. Let's see. What is 2 minus 5? Negative 3 plus 3, and that is 0 equal to 0, and that is true. Damn. Pretty cool, huh? What's that? I know, right? Let's go to the next one. Example number 4. Oh, okay. Copy that, please. What's that? No, we're going to do it together. Example number 4. Here we go. Copy this one. Example 4 says x minus 7 times x plus 2 equal to 0. You're like, wait a minute. They already did a bunch of work for me. Watch, so let me go back to the previous one. Everybody look up. Look at the previous one. Look at the previous one. From here, didn't we just do set each one equal to 0 and solve? Aren't we there here? Yeah, they already did all the factoring and all that for us. So what is our next step? Tell your neighbor, please. Okay. So I heard set each one equal to 0. X minus 7 equal to 0. X plus 2 equal to 0. Are we there? And let's solve for the variable. So this is plus 7 plus 7. X equals 7. Minus 2 minus 2. X equals negative 2. So on this one, they're asking us to solve the equation. These are the roots, x-intercepts, or zeros. So if they were just to ask you for the solution, what are your solutions? 7 and -2. Those are my solutions. But of course, Mr. Q is not just going to let you get off like that, right? No, because what do we need to do? We need to graph. Yay! That's what we're going to figure out. Yay! Here we go. So, draw your coordinate plane. Oh, you know why we're going to look for y? All right. Here we go. You see what I did right there? All right. So, my x-intercepts are x equals 7. 7 is over here. Okay. -2 is about right third. But you're saying, Mr. Q, we don't have a y. So, pay attention, pens down really quick. Where did we get the y-intercept over here from? From the equation that has the trinomial, right? So think about it. How can I get a trinomial if they only give me these two things? Don't say it out loud. Let me help you. Let me help you. Watch. Look at that. How can I get a trinomial out of that? The area model. Yay! So, those of you that saw it, who saw it? Okay. If you don't want to use the area model, if you want to distribute, that's fine. Then you need to do the area model. Here we go. X minus 7, x plus 2. So let's see, x times x, that's x squared. X times 2, that's 2x. -7 times x, that's -7x. -4 times 2, that's -14. So what do you mean my y-intercept? What is it? So you put that down here, label it -14, and that's our graph. Here it goes. Bam. For rallies. So now, they're asking us to check. No, they did say, so check this out. I'm going to write, pay attention to this. I'm going to pick one of these points. Which one should I use? 7? Okay, I'm going to use 7. This is 7, 0. I need to substitute into the original equation, but we don't have an original equation, but we do have some variables, right? And what was this 0 before it came 0? Y. So therefore, I'm going to use this equation to check. Check this out. Parentheses, instead of x, I'm going to substitute what number? 7 minus 7, close parentheses, open parentheses, 7 plus 2, close parentheses, equals, what is y? 0. But you see where we get 0 from? Okay, so what is 7 minus 7? What is 0 times 9? So is 0 equal to 0? Yes. Bam. Pretty good, right? Okay, so that's pretty much the homework for tonight. Now, check this out. Let's do one more. Do we have time? No. Okay. Let me go to the next one. Here it goes. You don't have to copy, just pay attention. Here it goes. So look at this one, example 5. Okay, example 5, x minus 2 times x equals 0. This one they already did a bunch of work for us, right? So what would be our next step? Yeah. Very good. Set each one equal to 0. X minus 2 equal to 0 and x equal to 0. So one's already solved. This one we need to solve. Plus 2 plus 2, x equal 2. So what are these called? Solutions, which are my roots, x-intercepts, and my zeros. So now check this out. If I was to graph these, pay attention, because this is going to be the one that you're going to be like, oh, here it goes. One intercept is at 0. The other one is at 2. And you're saying, don't we need a y-intercept? Well, check this out. Isn't this point also on the y-axis? Yeah. So therefore, that same x-intercept is also my y-intercept. Boom. Just like that. Everybody see that? So homework. Homework is found on page what? 579, numbers 1 through 31 odd. Good one to you guys in tutoring. If not, tomorrow. Do your homework, guys. Bye.